In this problem, we need to find the exact values for sine of theta, cosine theta, and tangent of theta, and we're given cosine of 2 theta. And we're given this location of 2 theta. So we're given information about 2 theta, and we want half of that angle, theta. So we can use our half angle identities, which I've listed here in blue, green, and purple. And I also want to look at where theta is located. So if I know 2 theta is in Q2, that means theta must be in Q1. Okay, so that means cosine, tangent, and sine will all be positive. So that means that looking at these formulas, I know that this is going to be a plus. So I can drop the signs and just have it as positive, since I know that it'll be cosine, sine, and tangent of theta will be positive. So let's make these formulas work for us. So what is alpha here? So the information we're given is 2 theta, and the information we want is theta. So if we let alpha be that information that we're given, 2 theta, then theta ends up being the alpha over 2. That goes in there. So that means we're finding cosine of theta if we find cosine of alpha over 2, which is what we want. So let's start with that. Oh, I'm sorry, that's blue. Okay, so cosine of alpha over 2, with alpha being 2 theta, is cosine of theta. And then that equation will be positive, because it's in Q1, square root of 1 plus, and alpha again is 2 theta. So I want cosine of 2 theta here, all over 2. And I have cosine of 2 theta right here. So I'll fill that in. One plus a negative, so I'll just write minus 41 over 841 all over 2. And now I need to get my common denominator to do that subtraction, which gives me an 841 over 841 minus 41 over 841. And all that divided by 2. I'm going to make my square root a little bigger so I know that 2 is under there too. And that will give me square root of 800 divided by 841. And then divided by 2 is the same as times 1/2. So I'll write it like that this time. And I get so that is, okay, I'm going to reduce a little bit here. So I'll use my red. So that 2 and the 800 cancel or reduce, and I'm left with square root of 400 over square root of 841. And those are both perfect squares. So square root of 400 is 20. Square root of 841 is 29. So I'm left with a cosine equals 20 over 29. Okay, and then I have a similar process for sine. The only thing that really changes is this sign right here. That's now a negative. So I can start with the work I already started. I can actually start from right here and just change that sign. So I get this equals square root of 841 over 841. This time it's going to be plus, because it's minus a negative, 41 over 841 over 2. And that gives me square root of 882 over 841 divided by 2 is the same as times 1/2, and I can use that to reduce again, so that 2 cancels with this to give me 441, which is square root. So I'm left with square root of 441 over square root of 841. And those are two perfect square roots too. Square root of 441 is 21, and the square root of 841 is 29. Now tangent, we do have a half angle identity for tangent, but we don't necessarily need it in this case because we already solved for sine and cosine, and I know tangent is sine divided by cosine. So for tangent of theta, I will just do sine of theta over cosine of theta, and I already have those over here. So sine of theta is here. So if I do sine divided by cosine, that means I take the 21 over 29 divided by 20 over 29. My denominators will cancel, and I'm left with 21 over 20 as my final answer.